with a beautiful sunrise, and shrouded by that protective fairing is the Perseverance rover headed to Mars. This is a life-size mock-up of the Perseverance rover, which is just like the one we are launching to space.
NASA CE.
NASA CE is go.
SMA.
SMA is go.
NASA team is ready to proceed.
Engine ignition, 2, 1, 0.
Release.
And liftoff. As the countdown to Mars continues, the perseverance of humanity launching the next generation of robotic explorers to the Red Planet.
And we have good indication of SRB jettison of all 4 SRBs. We have good indication of payload fairing jettison. And we have successful separation of Mars 2020 with the Perseverance rover.
And welcome to NASA's post-launch press conference here at the Kennedy Space Center. I'm Daryl Nail, and as you just saw, there was a successful launch of an Atlas V rocket by United Launch Alliance and NASA, sending the Mars Perseverance rover to the Red Planet. We have some special guests here now to talk about the launch, and I want to get to those right now. To my left, we begin with Jim Bridenstine, the NASA administrator. We also have Thomas Zurbuchen, NASA's Science Associate Administrator. Lori Glaze is here. She is the Planetary Science Division Director at NASA headquarters. And we have Matt Wallace, Deputy Project Manager with NASA's Jet Propulsion Laboratory. Omar Baez, he is our Launch Director at NASA's Launch Services Program. And Tori Bruno, President and CEO of United Launch Alliance. Thank you all for being here. We're going to get started with our administrator and a few comments. Of course, it was an incredible launch here at the Kennedy Space Center, and a successful one at that, sending the rover on its way. We understand there is a small communication issue with the spacecraft, and we're going to let Jim start us off and talk about that. Jim?
Oh, you bet. Thank you, Daryl. So first of all, it was an amazing launch, very successful. It went right on time, and of course, it is on a trajectory that has been done now with pinpoint accuracy. The spacecraft rotates, so it's stable, and it is in fact on its way to Mars. You mentioned the communications issue, and we can call it an issue. I know there's maybe some folks in the media that would call it an issue. But really, it's something that we've seen before with other Mars missions, as a matter of fact. And what's happening is, we're using the Deep Space Network to receive the signals from the spacecraft right now. Well, the Deep Space Network is a very sensitive receiver. It's designed to capture, very faint signals from deep space. And of course, the spacecraft right now is yes, it's in deep space. It's a good distance from the Earth, but it is not the distance that we would normally be receiving from using the Deep Space Network. So what this does is it puts us in a position where the carrier wave is actually, we have a strong carrier wave, a strong signal, but we haven't been able to lock onto the modulation of that signal to receive the data. This is not unusual. Everything is going according to plan. We do need to, fine-tune our receiving stations on the ground and do some things to capture that signal and lock on. But I think we're in great shape. It was a great day for NASA. And I just want to say thank you to our partners at United Launch Alliance. Tori Bruno, your team did an absolute magnificent job. It couldn't have gone any better from a launch perspective. And of course, our team at JPL, which has worked so hard to put this mission together. So the whole NASA team is grateful for the people that made this come together. So thank you, Daryl, and look forward to hearing from the others and answering questions.
Absolutely, and thank you, Jim. Let's start with you, Dr. Z. Successful launch. There's still a lot to go. What are your feelings now after experiencing this and seeing this science mission on its way?
I'm relieved. It's a space mission now, right? It used to be an engineering project on the ground. It's a space station, a space mission now, and it's on the way to Mars. That's exactly what we hope we will be at right now. And you know, the one thing that I want to do also is just add my gratitude. You know, Launch Services, United Launch Alliance, you know, getting this done. And of course, JPL. You know, and the many partners, both international and domestic commercial partners that got us there. And I just really want to thank. I want to also tell you about something else I'm proud of, and that is that this entire launch, from the beginning, with all the uncertainty that the launch brings, through now, we do so with cameras on, and we communicate clearly and directly and openly. We believe, and I know we feel exactly the same way, Jim, is that inspiration comes from taking that risk and making it really clear and open what all the successes are. And every once in a while, you know, where we need 2 attempts to get this down and you know, on the green and down, you know. So the point is, this is just a space mission. I look at 100 space missions or so each day in my email, and issues of that type and others occur. And we communicate that openly, and I just think that's where the inspiration comes from. I was so excited, for example, to meet these 2 7th graders that did name Perseverance and Ingenuity, and just learned from them how inspired they were from this launch. So I really just so grateful and so excited for this mission.
You can certainly tell they enjoyed their time here watching from the 5th floor and getting all the excitement that goes into watching something they helped name go up into space. Lori, let's get to you now. You've got something, a little fun planned for us, right?
I do, but before we get to that, I want to just take a moment also to thank, of course, ULA and LSP and JPL and all of the scientists and engineers that worked on the Mars 2020 project. All of them that got us here today. We wouldn't be here without the entire team, so thanks go to all of them. I do have something a little special for folks today. We are, of course, with this mission, taking the whole world with us on our way to Mars, and as part of that, we ran a campaign with JPL to invite the world to help us with the countdown to Mars. And so what I'd like to do is share that a little short video that we've put together with the help of folks all around the world.
Let's light this candle. 10, 9,
8,
7, 6, 5,
4,
3,
2, 1.
0. And liftoff as the countdown to Mars continues.
blast off. Listo. Lift off. Lift off.
The perseverance of humanity launching the next generation of robotic explorers to the Red Planet.
Bon voyage.
Welcome back, Perseverance.
You are Perseverance.
Well, that was great, Lori.
Great.
Really enjoyed seeing all those kids from around the world helping out and contributing some of their creative genius to our mission here. We want to turn now our attention to Matt Wallace, the Deputy Project Manager, who looks like you were doing some communicating yourself over there. Tell us what the, what the latest is with the rover.
Yeah, I was just getting an update. Let me just start, though, by saying, express my gratitude and the gratitude of the team for the people over here to my right, which have supported this project for 7, 8 years, for a long, long time, especially over the last couple months when we were going through the the very strenuous period dealing with the pandemic. It really took the entire agency to step up and help us, and they didn't hesitate, and they did it, and we really appreciate that. I also want to just say you're going to hear from the ULA and launch services team after me, but they gave us a perfect launch this morning, right down the middle. Couldn't have aimed us any better. We look great coming off the Centaur, and they really pushed hard to keep us on this limited planetary launch window in 2020. As most of you know, if you miss this window, you got to wait a couple years, and so it was critically important for us to hit this. And I can't say enough about the professionalism and the support they gave us over the last couple months in particular. And then also, I want to thank the team. You know, the team out there, thousands of people that have really stepped up and made this a special mission. As people have alluded to, Perseverance has become a pretty good name for this mission. So let me talk a little bit about what we've been dealing with just today. As I said, the spacecraft looked great pre-launch. We went into launch mode. We get telemetry via the launch vehicle, telemetry communication all the way through separation of the upper stage. And then we go into a period where we have to wait until we come out of the eclipse of the Earth. Essentially, the Earth is shadowing the sun, and therefore the spacecraft doesn't have a lot of power. And so we don't turn on our high-power transmitter, and we wait until we're in a better power situation to do that. So at about 9:15 or so this morning, as expected, the transmitter turned on. The signal strength looked very good at the receive station. There were really no indications of any issues. The navigation signal, the Doppler that we analyzed to make sure we're on the right trajectory, looked very good. The one problem we had is we couldn't, the terminology that we use is we couldn't lock up our telemetry. And so basically what that means is that we have to modulate our telemetry on a subcarrier, and then we have to demodulate that subcarrier, and which sounds pretty technical, but basically it allows us to read the information and the data coming from the spacecraft. Now, it turns out that the Deep Space Network is really designed to talk to spacecraft that are a long, long way away. You know, spacecraft like Voyager, which are tens of billions of miles away. And so they have very sensitive receivers, very big antennas, and to configure them, in fact, to talk to a spacecraft that is this close to the Earth is a little out of the ordinary. And so we know, and we have had issues in the past before. In fact, the last mission I worked on, the Curiosity mission, which launched in 2011, had this issue where we were basically saturating the receiver at the ground station. And so it takes us a little while to essentially figure out how to configure the ground station such that we're able to demodulate that telemetry signal and get the information from the spacecraft. And that's what we've been working through over the last hour and a half or so since the transmitter turned on. I did, just as the administrator was speaking, I did just get a text that we were able to lock up on that telemetry. And so we'll be starting to get some information on spacecraft and spacecraft health very soon. The good news, though, is that all the indications that we have, and we have quite a few, are that the spacecraft's just fine. It's a very stable spacecraft. It's a spinning spacecraft. Our Centaur upper stage, in fact, spins us at about 2.5 revolutions per minute, which means the spacecraft is hard to kind of knock off course. It's like a spinning top. You can't knock it over. And so it's very stable. We know it's getting good power. We know, as I said, the transmitter's on. And so it's really just taking a look now at the telemetry, which we've now locked up on, and getting a health status from the team. And so that'll happen shortly.
All right. Thank you very much for that
Sure.
update. That is great news to hear. Let's turn now to Omar Baez, the launch director from NASA's Launch Services Program, getting a lot of accolades. So, Omar, how did you feel the team performed today?
Oh, fantastic. Honored, proud. Those are the kind of words that I can think of right now. Ecstatic, It was a very quiet count for us. About the only excitement was a couple of instruments dropping out with the range, and then at about 20 minutes, Matt came over to us and said, "Hey, we just had a earthquake in Pasadena, and we'll see if we're still okay as far as the control room there and the information they were getting." And they responded back really quick. And I'm pleased to say we hit it right at the beginning of the window. The vehicle performed perfectly. We released them at just over 25,000 miles an hour, so we'll make that separation distance in a couple of days that you need for locking on. It'll become easier. So Daryl, just proud to be a part of this. I've been with this with Matt and company, and so has the predecessor to the Launch Services Program. From when we did Sojourner, we had less gray hair then, but it's just a proud moment, and I'm glad to be a part of it. And I'm glad that our program could provide what they needed to get this on its way.
Congratulations again to your team. You certainly had a good partner in this effort, United Launch Alliance. And so now we'll turn to Tori Bruno, the CEO and president of ULA. Tori, you said that this rocket would leap off the pad, and indeed it did. That thing got out of here in a hurry.
Yes, it did. It was a beautiful day, as you saw in the video, and the winds were nearly dead calm out at the pad. And so, as you heard, we ignited. The Atlas performed really nominally throughout the mission, and we ended with just an extraordinarily accurate orbital insertion. And really the only excitement that we had today at all is what Omar referred to, where people in California thought they felt an earthquake, but really they were just feeling mighty Atlas crouching down to leap off the Earth.
Thank you very much, Tori. We appreciate that. A little rumble in California and some rumble here in Florida. All right, we are now going to go to the phones and get some questions from our media members out there, and we'll also take questions from social media at the hashtag Countdown to Mars. We will begin with Paul Brinkman, who is on the phone, who is with UPI. Paul, go ahead.
Hi, yeah, thanks very much. So we're talking about launch here, but all of this is aimed at proper Mars arrival in 7 months. So can I ask one of you, I guess Matt Wallace, to talk about that next big step in this process? How do you verify that the craft has properly arrived at Mars? And then for the entry and landing, is this basically a total copy of the EDL for our Curiosity, or how is it different?
Yeah, sure. I can take a shot at some of those. Well, we'll spend the next 6.5 months or so in cruise, and we'll do a lot of engineering checkouts and health checks and make sure the spacecraft is ready to go for entry, descent, and landing. It is definitely by far the most difficult part of the mission. The spacecraft has to perform the entire process of getting down to the surface autonomously. There's no human interaction with the spacecraft during that period of time. And basically we start prepping for it maybe 8 days out or so. And as we get closer and closer to the outer atmosphere, there's more and more autonomy, especially this spacecraft essentially starts to do what it needs to do on its own without our interaction. And then we do land in a way that's very similar to a Curiosity. We were able to leverage a lot of the investment we made in that mission, getting Curiosity down to Gale Crater. So we come in, on the order of 12,000 miles an hour. Our entry capsule will slow us down. We will steer that entry capsule hypersonically so that we aim right at our landing site. And then when we're still moving at about Mach 2, we inflate our big supersonic parachute. It's about a 70-foot chute. That's an exciting moment in the mission, and that'll slow us down to maybe 150 miles an hour or so. And then the heat shield, the bottom of the entry capsule, drops off when we start to acquire the ground. At this point, we do something a little bit different than Curiosity did. We have a new capability. It's a hazard avoidance capability, and it's a very powerful new system. We call it terrain relative navigation, and it's actually enabled us to target Jezero Crater, which is a location we could not have gotten into with the Curiosity MSL mission. There are just too many landing hazards. But the way it works is we take a picture as we're coming down, and then we find ourselves in a map that we have stored on board from orbital imagery. And once we know where we are in that map, we essentially divert the spacecraft away from the hazards that could be dangerous to it during landing. And we do that during what we call powered descent. We have something called a descent stage, which carries the rover with 8 big main engines down to the surface. As the rover gets close to the surface, it deploys down on a tether. That's a maneuver we call the sky crane maneuver. The rover will touch down on its wheels, we'll cut the tether, and we'll be ready to go on the surface. So there are a lot of similarities, but we have some new capabilities as well to help us get into these more scientifically interesting sites like Jezero.
All right, thank you very much. The only thing is we have to wait 6.5 months for all this. Thanks for describing those exciting moments that will be happening in that time, February 18th, right, 2021. Our next question comes to us from Marcia Dunn with Associated Press. Go ahead, Marcia.
Yes, hi. Probably for Matt. I'm wondering, provided this lock on the data stays solid, how much longer do we have to wait to get a full read on the spacecraft health? And I'm wondering, up until the time you got that text a few minutes ago, if this led to some extra sweaty palms, a little bit of heart fluttering until after a long day. Thanks.
I'm not sure I heard the entire question, but I think the first part was associated with how long it would take before we had some spacecraft telemetry. The team will be pouring through that telemetry, as we speak. I would say another 30 to 60 minutes or so. We'll have a pretty good understanding of, the different spacecraft systems. They'll be looking at the power production out of the solar arrays. They'll look at the temperatures around the spacecraft, the thermal conditions. We'll obviously be taking a look at the telecommunication systems, be looking for any other faults or anomalies, obviously, on the spacecraft. But I would say on the order of 30 to 60 minutes or so from now, we'll have an update probably.
And the second part of our question was, how are you feeling after this successful launch and this first part of the mission?
It's it is always a bit of relief when you get through the launch cycle and the spacecraft separates. The spacecraft is really designed to operate, as I think Thomas was saying, in space. That's where it's happiest. Most of the problems we run into are because we're in a test configuration that's not really flight-like, interestingly enough. And so I think the team is obviously very relieved to be on our way, and the spacecraft is generally is as well. So yeah.
Very good. Our next question comes to us from Lauren Grush with The Verge. Lauren?
Hi, thank you so much for taking my question, and congrats on the launch today. I'm curious, is there any extra risk introduced by not being able to communicate with the spacecraft right at the time of signal acquisition, or is it really just peace of mind ahead of your first big maneuver? And also, had you prepped for the possibility of this communication problem since it happened with Curiosity? Thank you.
What was the first part of the question? I couldn't quite hear.
She was asking about the communication with the spacecraft in terms of getting that acquisition to signal. Is it a problem that you don't lock in initially?
No, well, as I said, the spacecraft is, as I just finished saying, is really designed to be in space. It's a very inherently stable spacecraft. We've got plenty of time to work through the communication issues. There's nothing that we need to do urgently. In fact, we got such a good, insertion from the launch vehicle. We've got plenty of time before we have to make our first trajectory correction maneuver. Nominally, it's about 15 days after launch, but we probably have time well beyond that based on how well we did. So we got plenty of time to, to get the signal and to start interacting with the spacecraft and doing those sorts of things.
All right. Let's turn now to Irene Klotz, who is with Aviation Week. Irene, go ahead.
Thanks very much. I may have, I'm not sure if I heard this correctly, but once the spacecraft reaches, is it 25,000 miles that this issue becomes moot, whether or not you're able to do the comms by modulating the signal or not? And that's for Matt. In other words, how far away does Perseverance need to be before it enters the true deep space mode of communication?
Yeah, I think it was Tori or maybe Omar that said the spacecraft's moving pretty fast, 25,000 miles an hour when it comes off that upper stage. And so the point that they were making is that we're putting distance between the spacecraft and the Earth pretty quickly. And so that helps a lot with respect to the saturation of the ground station radios. And so really within hours, the power will drop. And that can help, certainly, yeah.
And real quick, Omar, what were the numbers on the release of the spacecraft?
It's just over 25,000 miles
per hour. Okay, very good. All right, let's turn now to Russell Pins, who is with Pacific Rim Media. Russell, go ahead and ask your question.
Good morning. Yeah, that's Russell Pounds, calling from Alaska today. And this is for Administrator Bridenstine. The question is, when does the light go on for students that America's investment in space exploration is worth the money? And then as a follow-up for adults, if it's a different kind of time when they realize, oh, this is worth our while, when is it that happens?
Oh, I think it's already happened, and I think, when you think about Mars Perseverance, that's evidence that it has happened. We just had a few folks here on the panel talk about Sojourner and its success, and then of course Spirit and Opportunity and the success of those robots, and then Curiosity and now Perseverance. Look, every single one of these missions gets more complex and more sophisticated, and right now we have the single most sophisticated, complex robot ever sent to another world, and so we're very excited about it. But I think the American people see the benefit of these activities, not just in terms of science, but also in the development of technology that we all benefit from. So I think as far as the American public goes, there's a lot of enthusiasm for these missions. And of course, as far as children go, these are the kind of moments where people decide, young folks can decide, wow, that's something I want to do when I grow up, and they go into the STEM fields and they get interested in STEM activities. So I think all of America is very proud and excited about this mission, and the ones that in fact came before it, and the ones that are operating on Mars right now today.
We certainly got a sample of that from Lori's video and some of the kids that we saw there. Let's pause for a second and ask a question to Omar while we are waiting for these 7 months for Mars Perseverance to land. What is next for LSP?
So LSP's next launch is the Microfrylix Sentinel-6 mission out of Vandenberg, and that's in November. But we do have a very full manifest of other missions that are in queue. So yeah, next up in the lineup for launch, Sentinel-6, and quite a few other missions to fly out in a year later.
Good to hear the manifest is full over there. For Tori, ULA has launched 4 previous missions to Mars on an Atlas V. Was there anything different that you did with this configuration that was different than the others?
Yeah, there was. So there were probably 2 important things that were different. The first was that the planetary protection requirements in terms of cleanliness and biological contamination were updated for this mission, making this probably the cleanest spacecraft that has ever gone to space. That was a significant challenge. And then we combined that with another new thing, which was to bring in the nuclear battery, the multi-mission radioisotope thermoelectric generator, laid into the flow and actually breach that encapsulated volume where we keep the ultra-clean spacecraft, where it was prepared in its own facility in order to install the battery out near the pad in what is essentially an outdoor vertical integration facility. And so that meant constructing a clean room that could be put onto the VIF on a platform and then have people come in there and do that work while maintaining all of those protocols, both handling of the plutonium as well as protecting Mars from the spacecraft itself so that the experiments could be successful. So that was a pretty big challenge for our people, and of course they had to do it in the midst of COVID just like your teams did, and I could not be more proud and more humbled by the courage and the dedication of my launch team that just pulled all that off.
And congratulations on that great work. Going to go back to the phone bridge now, and we'll get a question from Leo Enright, who is with Irish Television.
Thanks very much, and congratulations on the launch today. A couple of questions. One for the rocket people, as it were, about spacecraft separation. We saw a blink and you miss it video of spacecraft SEP. I just wondered if we're going to see any further video, or is that it? And then for Matt Wallace, if I may, could you be a bit specific about what time of day you're planning to land on Mars? It helps us TV people plan ahead. Is it morning, noon, or middle of the night?
Well, as far as the landing goes, I'll have to get you the specific information, make sure I don't give you the wrong time. And I'll let Omar and Tori answer the other question.
I can go. Yeah, so we have a little bit more video than that. I mean, we can certainly make it available, but what you saw is what you saw. It came off very, very clean, 2.5 RPM, and it just gets further and further away until it disappears. But what I will commit to do for you, as I always do for every mission, I will publish the bullseye chart, as we call it, that shows you all of the significant orbital parameters relative to the error that we were allowed that would have been within the spacecraft's capability to correct its trajectory. It's going to be pretty close to plus or minus perfect, and I will tweet that probably in the next day or two once we get it all processed.
Looking forward to that report card.
The video of it separating is one thing, but the video, we're going to get kind of new imagery that we've never been able to get before on the entry, descent, and landing. Can you talk about that?
This mission has more cameras on it than any mission we've ever sent before, and I think the images and the video that we're going to get back from the Perseverance rover during that entry, descent, and landing, and then once it's on the surface as well, is just going to be absolutely stunning. We'll be able to capture what it looks like coming down. I believe there's cameras looking up to get the parachute. We've got, it is extremely well equipped, and I think it's, again, going to be something that we can feel like we're actually there riding along with Perseverance on the way down.
We're going to see images of the sky crane.
We are, yeah. And in fact, what the administrator is referring to is we took some ruggedized commercial cameras, the type of kind of sport cameras you might see in extreme sport enthusiasts and that type of thing. And we basically distributed them around the spacecraft. And so we will, in fact, be able to see that big 70-foot supersonic parachute inflate in a tenth of a second, and we'll be able to see those big main engines fire on the descent stage, and the rover drop down on its tether. We'll be able to see the rover touch down and the descent stage fly away. And I do want to say that one of the things that inspired us to add these cameras were the terrific imagery that we see coming off the launch vehicle. It was time to have the opportunity to see a spacecraft land on another planet for the first time. It was time to do that, and we were pleased to be able to get them on the spacecraft.
I've seen video from a rocket landing on Earth, and now to see this video landing on another planet, it just something I'm really looking forward to. And of course, stay tuned to NASA's social media accounts. You will likely see it there pretty quickly. From We're going to go now to Lori to tell us about the Mars helicopter Ingenuity.
All right. So this is going to be a fantastic experiment. I think we're really, really looking forward to this. I'm not sure that people really can sometimes grasp just how difficult it is to fly. And this is going to be, of course, our first ever demonstration of powered flight on another planet. But if you think what's required to fly, to get lift from a wing, you need air to do that, of course. And the atmosphere on Mars is about 1% of the density of Earth's atmosphere. And so without that air, getting lift and being able to actually fly is something that's extremely challenging. But the engineers out at JPL demonstrated that they could actually get that lift and fly a helicopter in that very, very low density type of atmosphere. And so we are really, really excited to do this and demonstrate that capability. I think going forward for scientific purposes and also in preparation for human exploration, I think these types of aerial robotic capabilities are really going to add to the type of science we can do. We'll be able to use such a helicopter to do things like do some pre-surveillance, do some reconnaissance of various areas that we want to decide, do we really want to drive over or go over and look over there. Send them into areas that perhaps are of such scientific specialty that we don't really want, we really want to make sure we don't contaminate them in any way. So we're going to send something over there to do a special experiment and bring it back so we don't have to take everything over. I think these are really going to expand and change the way we think about doing exploration on other planetary surfaces. So really, really looking forward to this.
Very excited to see that as well, Lori. Mm-hmm. Okay, let's go back to the media phone bridge now and take a question from Joey Roulette with Reuters. Joey?
Hey, thanks for doing this. I was just wondering, what is the total distance Perseverance will travel in the next 7 months, and how patient will the team at JPL have to be during that time? And I also just wanted to follow up on Marcia's question earlier to Matt. What were the feelings in the room when the teams were working through that comms issue after a long launch day? Were there sweaty palms or any nerves? Thanks.
Dr. Z, why don't you take the trip to Mars? How long is it? The distance?
6.5 months.
What's that?
He wanted it in miles.
Length of time, the miles? Yeah.
Oh, did he ask the distance, I believe?
Oh, the distance.
Distance traversed.
100 million miles, to travel from here to Mars. And the team will. They still got plenty of preparation to do for entry, descent, and landing, and surface operations. So they'll be busy during that period of time for sure.
I do want to talk about the second question. It's like, how was it when the team addressed this issue? I just want to tell you, like it always is. You want to be a rocket scientist, this is what you do. It's like, we're not just scoring hole-in-ones every time. And what we do is we let the people work. We had Matt talking to us, and we let him work, and we listened what he had to say. We did not add data. We listened what we had to say. We communicated it like we always do. It's like we always do it. It's just, you have to have a little bit of nerves if you're in that business. But the point is, that's why we love it so much. It's because we solve problems together as teams. Right now, I know, I do not see them right now, but I feel them. Right now, there are these amazing JPLers sitting there in Pasadena. There's some people right here solving this problem right now. Before I go to bed, I will know what it is in detail. I'll take any bet with anybody who wants that right now. Why do I do that? Because I observe it every time. And, whether that's with JPL, whether that's with Goddard, whether that's with Lockheed Martin, this is the commitment that it takes. And so for me, it was exactly like it always is. It's just an issue. It's rocket science.
Excellent. No takers on that bet here. Let's go back to the phone. And Mary Liz Bender from Inverse, you have a question?
Yes, thank you so much. Wow, that was such a beautiful launch today. Congratulations. I am really excited about all of the new functionality on this rover. I've been talking to the JPL engineers all week about how we keep stepping up the rover status. And now I know we're working toward getting to a place where we can have huge rovers that can assist humans in our exploration of Mars. So I'm just curious, what are kind of the steps that take us from here to there? I'm sure we don't know everything, but what do you kind of see as maybe the next set of missions, and how might they improve on this one?
I can take that one. So I think the next step that's going to move us along towards human exploration that we'd like to see at some point in the decades to come here is the Mars sample return mission. This is the very next mission to Mars that'll follow on after Perseverance, and it's actually the next step in trying to go back to Mars and collect the samples that Perseverance is going to store on the surface for us. And that Mars sample return mission is actually going to demonstrate even more capabilities that we're going to need in order to explore with humans at Mars. First off, that mission is going to have to be able to demonstrate how to launch from the surface of Mars. We're going to send a rocket, the Mars Ascent Vehicle, to Mars. We're going to have to get those samples and put them into that rocket and launch them into orbit at Mars. And we certainly are going to need that capability when we send humans. We're also going to demonstrate with that mission the ability to rendezvous in space around another planet. We're going to, when we launch that sample into orbit around Mars, we're going to have an orbiter there also at Mars, and it will hook up with that sample and capture it into a capture and containment system on the orbiter, and then we'll have to deorbit at Mars and return to Earth. And all of those technologies and all of those capabilities are going to be necessary when we send humans. So I think we just, with each mission, with each robotic mission, we demonstrate those next capabilities that we're going to need and build the bridge that we're going to need to get to human exploration.
All right, thank you, Lori. Yes, sir.
And that is that there's three more things that are really important. The first one is that actually, roughly in the same time frame, we're trying to design an ice mapper, one that is really focused on actually finding water resources, because also that we want to have available for humans when we're going. It's part of our budget that's under consideration on the Hill. I think the second thing I want to say for the science community, this is a really interesting decadal that just started, because this decadal has a lot more opportunity focused on the collaboration with human exploration than in the past. And the third piece is, increasingly, as we go to the moon with astronauts, we learn back all these things that in the past perhaps we knew, but in entirely new ways with commercial partner, with international partners. We're also going to learn how to build these capabilities that actually bring humans to Mars in the late 30s. So for us, that's really, these three things in parallel, over and above the Mars sample return, are just, really opening up the spectrum on Mars exploration to a level which no other decade really has in the past.
All right, thank you, Dr. Z. We have some questions on social media that we're going to get to in just a second, but first let's get a question in from Eric Berger with Ars Technica. Eric?
Hi, congratulations, everyone. Thanks for doing this. Wondering if someone there could clarify whether the spacecraft is currently in safe mode, and if that's normal procedure for this time, and when it's going to be brought up to sort of regular operations in deep space. Thank you.
So when we started this discussion, we weren't really sure, but it appears as though we came off the launch vehicle in our normal cruise mode. I'm just getting some indications that we had a minor temperature transient that's recovered that may have put us into safe mode. If so, that's perfectly fine. The spacecraft is happy there. So the team is working through that telemetry. They're going to look through the rest of the spacecraft health. So far, everything I've seen looks good. And so we'll know more in a little bit.
And now to social media. James on Twitter asks, when is the landing date on Mars? We know that to be February 18th, 2021. I think at 3:30 Eastern. Is that something roughly like that? Stay tuned on that one. And then when is Ingenuity's first flight, Lori?
Question. Matt's going to have to give me some help here, but I believe it's about 30 to 60 days after we land.
We're hoping to get it done somewhere in that time frame, maybe 50 to 90 sols. Each day on Mars is called a sol, and so within the first 50 to 90 Mars days or so, we hope to fly start
Okay.
flying the helicopter.
Very good. Vizag on Twitter asks, how significant will it be to us humans if we find signatures of ancient life or maybe present life on Mars? Dr. Z?
Those are the kind of questions that, frankly, keep me up at night in excitement, not in worries like some other nights like the last one. Because if you look at history, recognitions like that, kind of new insight like this, have transformed not only how we think about ourselves, but frankly, how we think and act as humans, right? Kind of the recognition that the sun is the center of the solar system, not the Earth, had tremendous impact on Earth. And so for me, the life question is really quite foundational. I'm really interested in what the administrator says to this, right? Kind of for me, it's kind of as a scientist, it's really the holy grail. It's like, you know, when you go from n equals 1, there's only one life we've ever observed, to n equals many, multiple lives, everything changes. Like you can do research, you can ask questions, you have no clue how to even start, right? It's like opening up a whole new building of exploration in a way you never could. But how do you feel about it?
Well, I think there would be no bigger discovery in the history of humanity than finding life that is not on our own world. And I think it'll fundamentally transform how we do exploration in the future. We've been on this path of following the water to determine if some place is habitable or not. Now we know that there was, at one point in time, habitability on Mars. We don't know if it was inhabited, but if we were to make a discovery that it in fact was, I would imagine, you know, everything from that point forward is going to be, okay, what other life is out there? How do we get to it? How do we study it? How do we understand it? It'll be absolutely the biggest discovery, I think, in history. But I also think it will enable us to do more than we've ever been able to do before, because there will be such a profound interest in going further and doing more. So look, I mean, I think everybody's going to have to answer that question for themselves, but certainly there's a lot of interest in finding life that's not on this world, and that's what we're trying to do.
Absolutely, and thank you for that. One more question from social media. Dennis Morissette on Facebook asks, are the cameras on board Perseverance much better than those on Curiosity? And we understand that they are.
They are, yeah. We have a number of different cameras on board. I talked about the what we call the entry, descent, and landing cameras. Those are high definition 1080p type video cameras. We also have a set of science cameras at the top of the mast, which are called Mastcam Z cameras, and they're enhanced from the Curiosity cameras in that they have a zoom capability, and so those are also better. We also have a set of engineering cameras dispersed around the rover. Those engineering cameras we use to look at the surroundings, to look for hazards when we're driving, when we're doing our workspace operations with our robot arm, and those sorts of things. And those are significantly higher resolution than the ones on Curiosity. I think they're on the order of about 20 megapixels color cameras, and Curiosity carried 1 megapixel black and white cameras, just to give you a sense. So, yeah, we've kind of upgraded our cameras across the board on the vehicle. Yeah,
it's going to be like being there, 20 megapixel.
It will be, and we have a just add in. You know, we have a microphone as well. So not only will we be able to see things, but we'll be able to hear them as well for the first time. And so it's going to provide a real presence for us.
That's outstanding. All right, let's go to space.com, and we have a question from Megan Barteef. Go ahead, Megan.
Hi, Megan Barteef from space.com here. Thanks so much for taking my question. The first part of it is for, I think, Mr. Bridenstine or Dr. Glaze. I was hoping you could talk through sort of how exciting it is to get a planetary science mission like this off the ground in the middle of a pandemic. And then for Mr. Wallace, if you could talk a bit about what the next 7 months look like for the team and any way that that has been shaped or affected by the pandemic as well. Thanks so much.
Sure. You know, I'll start, and then I'll let Lori take it from there. But you know, when we think about this particular mission, when I first came to NASA, it was quite frankly in trouble, and people were worried about whether or not we were going to be able to launch in 2020 at all. And then we made it even more complex by saying, hey, we want to put a helicopter on here as well. We gave it the resources, we gave it the attention. JPL did a magnificent job. At one point we had a cracked heat shield, and of course Lockheed Martin and our partners there moved forward to get that fixed. So yes, adversity all along the way, but this is true for any project of this nature. But you know what? What we didn't expect was something that is, as you identified, the pandemic. And so you add all of the adversity in a project like this together, and then you put on top of that the coronavirus, and people, like a large fraction of NASA's workforce and JPL's workforce and the ULA workforce actually staying at home, and the other part, smaller parts of our organizations going to work with personal protective equipment, socially distanced, breaking up the shifts so that we can minimize the amount of contact. I'm not going to lie, it's a challenge. It's very stressful. But look, the teams made it happen, and I will tell you, I know Tori Bruno said it earlier, we could not be more proud of what this integrated team was able to pull off here. So yes, it's very, very exciting. Lori?
And I'll just echo some of what Jim just said there. Our teams across the board, this is, within NASA, at NASA headquarters, at multiple centers across the country, NASA centers across the country, at JPL, all came together to try and make sure that we got Mars 2020 to the launch pad today. It was truly a team effort, and in every single case, everyone stood up and said, yes, we want to do what we can to help. Whether it was providing aircraft to transport personnel, or whether it was, trying to make sure that we have the right protective equipment, that we were providing the support that the teams needed to come in to work if they were needed to put hands on hardware. But it was not easy, and as Jim says, a lot of our workforce has been working from home and trying to balance the work that had to get done with sharing the Wi-Fi bandwidth with their spouses, who are also trying to get their work done, and their kids are trying to do their school work and get their work done. It's been a real challenge, and I have to say that I think all of us within the Planetary Science Division are so excited and so happy that we were able to pull this off, to actually get it done. It was a lot of work, but I'm proud of my team. I'm proud of the JPL team. I'm proud of every one of them. We somehow made it through this.
All right, we'll get a question in from Keith Cowing with NASA Watch. Keith?
Thanks for giving us this opportunity today. Right now, the nation's in the midst of a pandemic nightmare, and it's not going to end anytime soon. It's going to be a dark, scary winter with 328 million Americans going to be, staring at their computers and their TVs, as will billions of people around the world. NASA's sending an astrobiology droid to Mars to look for evidence of life. It may discover that we're not alone. Now, how cool is that? It's been nearly half a century since the Viking landers attempted much the same task. Now, the world could use some good news right now. How is NASA going to involve the world in a way that speaks to the way that we're all isolated yet still connected? In essence, how will NASA make the Perseverance mission a bright light amidst an otherwise very gloomy winter?
No, that's an important question. I think the key word that you use there is the word astrobiology. I don't even know if maybe 10 years ago we even used that word, but now it's very apparent that we have water throughout our own solar system, and there are places in our own solar system that could in fact be habitable, not just in the ancient past, but even today. And so yeah, I think that putting together these kinds of missions that could not just inspire the next generations, but inspire those of us that are in the middle of our career or maybe even retired. These are the kind of things that NASA can do in very difficult times, and we're excited about it.
And we have a follow-up to that from Dr. Z.
I really appreciate that question, Keith. And you talked about this as a bright light. I believe that so much, and I think from the beginning, the administrator and I talked about it just that in those words, pretty much. And it's great to hear it from you also. You talked about how we're communicating with so many people, and I think the one thing we share here, and I know I speak for my friends on this panel, is that we really want to aspire to open up the communication in a more broad fashion to more people, to talk about the excitement of STEM research, the excitement of space research, the opportunities that come from that. It's exciting, and it's also good for the world. And so for us, the way we're doing that, of course, is as we innovate new missions, we try to innovate new communications. And I just want to tell you, one of the things that made me very proud today is the communication efforts that were set up during the entire week. This team at headquarters, led by Jim and his core group, Paul, one of your people there, I think did just an amazing job really telling the story more broadly. Really, yes, it's a launch, but it's the bright light we're talking about. Yes, it's a mission, but we're talking about transformative science and transformative exploration that goes beyond robotic exploration. And we think of this as a constant challenge, just like the missions need to be reinvented as we go, because we want to do new things. We also need to reinvent communication. I think the social media efforts that NASA has are second to none, but we should not sit still. We always want to go beyond that. We want to go to schools that have not heard that, because in that schoolroom, perhaps in a place where none of us has ever been, is that kid whose life are changing because she sees for the first time that she too could be part of this amazing thing, or something that's exciting to her, which is just as big. So I really appreciate the question, Keith. Yes, it's exciting what we're doing here, but the communication and how we talk about it is also really relevant. And I think we understand that, and we also recognize that we need to, as we go forward, learn and evolve.
And that was well communicated as well. Thank you, Dr. Z. The toughest question, we're going to slip one more in. We only have a few minutes left. Probably is the toughest. We'll let Jim decide, because it's going to you. Facebook, Eva asks, when do you project astronauts will arrive on Mars?
Well, I think it could definitely be technologically, it could be the mid-2030s. The risk here is not the technology and not the amazing teams that we have at NASA and with our commercial partners and international partners. The challenge is and always has been political. To do these kinds of missions requires budgets. I will tell you this, the President's budget request right now that is being considered by the House and the Senate is the highest budget that NASA has ever had in nominal dollars. The current budget that we have is the highest budget that we've ever had in nominal dollars, and next year it's going up even higher. And that's with bipartisan support in the House and the Senate. We have gotten the budget that we have. And of course, next year we want to get even more. And we need more because we need to go to the moon sustainably to prove that we can live and work on another world for long periods of time. And we go to the moon because it's always a 3-day journey home. And we can prove what we need to prove there so that we can eventually send humans to Mars. We've got the robotic precursor missions, which we've been talking about today, but we also have human precursor missions at the moon. We love Apollo. The challenge with Apollo is that it ended. And now we're going back to the moon with commercial partners and international partners under the Artemis program, learning how to use the resources of another world, in this case the moon, so we can apply all of that for our eventual long duration mission to Mars. We can do it. And of course it's going to require financial support. The House and the Senate are considering the budget right now. And I would just extend a request that when they think about these things for the budget request, think about what happened today. Think about what's going to happen in February when we land on Mars again, this time with an astrobiology mission and a helicopter and an ability to convert carbon dioxide into oxygen. Think about what we just did with launching American astronauts on American rockets for the first time since 9 years ago, 2011, the retirement of the space shuttles. Look, we can do these things. They require resources. They require the American public to believe in what we're doing. And of course, it requires mission success. And I will tell you, this team has proven that they can successfully accomplish these missions. If we were to receive the budgets, I'm very confident that we could get there by the mid-2030s.
All right, and we will close on that note. We appreciate all of you being here. Our special guests today, we know you woke up early, so thanks for sticking around and participating in this post-launch news conference. And thank you to all of our social media participants as well as members of the media. For more information on today's mission, you can go to nasa.gov, nasa.gov/perseverance, and mars.nasa.gov/perseverance. Thank you for joining us, everyone. Have a great day, and remember, keep looking up.
Chelsea Walker. I'm a materials and process design engineer for Northrop Grumman, the lead contractor for the solid rocket boosters of NASA's Space Launch System. This is rocket science in 60 seconds. These boosters produce 7.2 million pounds of thrust during liftoff and flight. I work on the insulation that protects the SLS solid rocket booster during flight. Here, in the Insulation and Component Work Center, the insulation, a rubber-based material, is applied to the inside of the rocket motor case to protect it from the burning propellant. Combine raw materials together through a 2-roll mill to form a sheet. We then apply the insulation to the metal rocket motor case. After the insulation is cured, a liner is applied. This is an adhesive that helps propellant stick to the insulation. Then the case is ready to go to our casting facility where it is loaded with propellant.
When I saw the country shutting down, I thought for sure there is no way we're going to be able to continue this.
It's something that nobody expected. It's something that nobody could plan for.
Rather than your first priority being mission success and getting to the launch pad, your first priority immediately gets displaced, and it's now the safety of the people.
I was seriously thinking Mars would be Mars 2022.
It took a lot of work to put stuff together in order to keep momentum going, to keep people working safely, keep them healthy, and to keep the project on schedule.
There's no doubt that working in isolation, not virtual isolation, but in physical isolation from everyone else, is a challenge.
It's hard for me. I have 2 young kids. Sometimes I'm not able to focus or listen probably as well as I would want to.
A lot of our work was occurring in a clean room anyways, but that meant that even before we entered the clean room, we had to find ways of ensuring that we were not putting ourselves or others at risk.
Most of the time for these missions, our relation with the spacecraft customer is incredibly important. So usually we're able to be here working beside them on their equipment and making sure that all of their needs are covered even before they ask for it. It is a challenge, but we're used to meeting unique requirements here at the hangar, and we pride ourselves in our flexibility.
This is just another mission, just with a different set of obstacles that we have to overcome. It might not be, like a broken rocket, but it's it's got its own challenges.
Our job is to go into the unknown, and this is just another example of the unknown. How to make this job happen when you're doing it largely through a computer screen.
I asked the team a couple months ago if they would like to do something to kind of symbolize and mark these challenges that we faced, and they designed something that we called a COVID-19 Perseverance plate that's now affixed to the port side of the rover. It has a globe representing all of us that face this challenge together, the spacecraft leaving the Earth on its way to Mars, and all of this supported by the now familiar staff and servant of the medical community. And we hope that this mission, in some small way, can inspire them in return. Pretty much everybody that I've talked to that's associated with the mission has said the same thing, which is you could not have come up with a better name than Perseverance.
We have persevered through this. Nobody's given up. We won't get this mission done. We will get it done through the pandemic.
I think it's a really important symbol of humanity, hopefully persevering through this great challenging time that we have right now.
We appreciate that team as well as the medical community that really stepped up and helped. And it's ironic, you know, Moo, because the name Perseverance was chosen by a 7th grader who at the time he submitted that name, he didn't know that we would be faced with a global pandemic. So we are glad to have him and his family here along with the student who named the helicopter to watch the launch in person.
Their names are Alexander Mather and Veniza Rupani, and they are watching from the 5th floor balcony of our engineering building, just a stone's throw away from the countdown clock. Look at that, there they are, looking cool. Alexander Mather, who goes to Lake Braddock Secondary School in Burke, Virginia, submitted the winning essay to name our rover Perseverance.
Yeah, they've got a great view. I've seen it from up there. They've got the VAB in the background, as you can see there, so
cool.
It's such a beautiful setup for this awesome launch. And Veniza, who you can see her and they're waving. Hey guys, appreciate you. She's a junior at Tuscaloosa County High School in Northport, Alabama. She entered the contest as well and came up with the name Ingenuity for our helicopter that will accompany our rover to Mars. Thank you both for being here. What a neat view that is.
Yes.
All right, folks, with the coast phase coming up, we want to let you know that after the launch, it will be about an hour before Mars Perseverance separates from the 2nd stage. When that happens, the rover will then be on its way to Mars, so hang in there.
Yeah, don't go away, as we will walk you through the flight around the Earth, and we'll talk live with the astronaut Zena Cardman about our human exploration ambitions and NASA's Associate Administrator of Science, Dr. Thomas Zurbuchen.
It's going to be great, folks, so stick around. It's L-6 minutes and 26 seconds now, and time to focus our attention on the launch operation the rest of the way to liftoff. So let's send it back out to Mick Woltman and Joshua Santoro. Gentlemen.
Thank you. I want to let you listen into the remainder of this poll in motion. Let's go to that now.
Range coordinator. Clear to proceed. Launch director.
LD is go, and you have permission to launch.
Proceeding with the count. ALC, verify T0 is set for 1150 Zulu.
So 11:50 Zulu, that is 7:50 a.m. Eastern time, so that time is correct.
As I'm watching Josh do the calculations on his finger there.
Get my abacus out.
Right.
No, so there's a lot to come ahead. One of the things coming up in just a few seconds.
5 minutes, 30 seconds.
OS,
NSC.
Go NSC.
Spacecraft on internal power and timer set for T0 of 1150 Zulu.
Roger. OS, start list data capture.
Roger.
Fantastic.
All steps are complete prior to terminal count. LC switch is ready.
Awesome. So things are really starting to pick up here. You're going to hear more and more chatter on those nets there. That call was to say that Perseverance is powered and ready to go, which is a phenomenal call.
Yeah, a couple things happened during that time, right? Is launch conductor, ULA's launch conductor, Scott Barney, polled the whole ULA team. They were all go. We got to hear
the third of our 5 teams.
The third of our 5 teams. We got to hear the end of that where the range was clear to proceed, and ULA's launch director, Bill Cullen, gave the authority to go for launch this morning at 7:50 a.m. Then we got to hear from the JPL spacecraft team that they are
the fourth team
that they are on internal power and timers are set. They are targeting a liftoff of 7:50 a.m. this morning. So all things are looking good for us, Joshua, this morning. It's so, we talk about being nervous and excited. This is right here where we're nervous and excited.
Yes.
There are a lot of things happening as we get ready to count down to the liftoff this morning. We have about 15 seconds left in this hold before we pick up the count.
Yeah, we're going to listen into that. The 5th team, the one we haven't mentioned yet, is the Department of Energy, who is responsible for the MMRTG, the power source for Perseverance.
3, 2, 1, mark.
Awesome. So this is now the terminal countdown. This is that time when things become more and more automated over the next few minutes, and the energy's building, but the focus is increasing exponentially.
Yeah, as Tori said during his interview, the teams are very disciplined, very focused on what they're doing, the operational sequence of events that they're following. They are making sure everything happens, especially in this T-4 and counting period, because there's a lot of things they have to do. They have to finish topping the vehicle, make sure that all the tanks, first stage, second stage on Centaur, are at flight pressures and full of fuel, ready to go for this morning. They have to make sure the FTS system is armed and ready for personnel safety just in case, so that the range can do that. They have to check the electrical and avionics systems. They have to make sure that the flight computer has all the information it needs to place Mars 2020 into the orbit it has to. So a lot of things going on. Exciting time for the team right now, but again, staying focused and following that procedure they've got.
3 minutes.
As we look ahead to post-liftoff, want to kind of preview for you what's going to happen because there's going to be a lot going on. You're not going to hear much from us. You'll actually be hearing from the ULA flight commentator, Jesse Gonzalez. He'll be kind of giving those calls past liftoff that will walk us through maximum dynamic pressure and into SRB separation and then into fairing separation, booster separation, and then the first main engine ignition of the Centaur,
yes.
RL-10. And so then you'll kind of hear us jump back in and help provide some more context to what's going on. We encourage you to stay with us for the rest of the show, though. There's a ton more content we have to bring you, and we are far from over. Want to emphasize that the countdown to Mars is not done at 0 today. The countdown to Mars ends in February when Mars 2020 safely delivers Perseverance and Ingenuity to the surface of the red planet. So we're going to let you listen in now and enjoy the last couple minutes of the process of launching a rocket.
One minute 59.
Vehicle internal.
1 minute 55.
Launch sequencer start.
1 minute 50.
Securing Centaur LH2.
Securing Centaur LO2.
So there we heard the fueling is
1
wrapping
minute
up
40.
there.
Yep, fueling is wrapping
Launch
up.
enabled.
Team is done. Launch enable's done. Launch conductor sequence is ready to go. They're getting ready to turn the vehicle over to auto sequence at T-minus 31 seconds. So that's a big thing that they're getting done here. At T-minus 25 seconds, we will hear the team give their final goes that everything is ready and
1
the
minute
launch
20.
vehicle is ready to lift off and perform this mission.
SCS count started.
1 minute 15.
Produce ACS for launch. Roger.
1 minute 10.
Vent valves locked.
One minute.
Rock, report range status.
Range green.
That's good to hear, Joshua, right there.
Public safety there is accounted for, the FTS system. There you see on your screen a beautiful shot. The skies look great. There is little wind happening. You'd be able to see more of the venting. If there were wind, the trail of that venting. So we're ready to go.
And actually, that's an important point. The reason we don't see that venting is the vent valves have been locked up to put flight pressure into the tanks. And as we just heard, they're stable at step 3, which means the tanks are ready to go. And here at about 5 seconds, we will hear the team
ECS reduced for launch.
Give their final go.
25 seconds.
Status check. Go Atlas.
Go Centaur.
Go Mars 2020.
And there we go. We are ready to go lift off this morning, Joshua.
Eight, 7, 6, 5, 4. Engine ignition. 2, 1, 0.
Release.
And liftoff. As the countdown to Mars continues, the perseverance of humanity launching the next generation of robotic explorers to the red planet.
And Atlas TU has gone to closed loop control. Coming up on 30 seconds into flight, the RD-180 is throttling down as expected. Engine response looks good. And Mach 1, Atlas 5 is now supersonic. And passing 45 seconds into flight, vehicle is now passing through max Q, maximum dynamic pressure. Passing 1 minute into flight, the RD-180 is throttling back up as expected. Engine response looks good. At this time in flight, the SRB chamber pressures remain nominal. The RD-180 pump speed and fuel injector pressures are responding well to demands on the engine. Standing by for SRB burnout shortly. And we have burnout on all 4 SRBs. Burnout pressure signatures look good. Standing by for SRB jettison shortly. And we have a good indication of SRB jettison of all 4 SRBs. And the vehicle has gone to closed loop guidance. Vehicle body rates are responding nominally at this time. And coming up on 2.5 minutes into flight, the RD-180 is throttled down slightly as expected. Engine response continues to look good. At this time, the vehicle is 50 miles in altitude, 85 miles downrange, traveling at 6,000 miles per hour. And the Centaur reaction control system is now pressurizing to flight levels. And just past 3 minutes into flight, the RD-180 is now throttling to maintain a constant 2.5 G acceleration limit for payload fairing jettison. Engine response and vehicle acceleration look good. And we have good indication of payload fairing jettison and Centaur forward load reactor deck jettison. And the RD-180 is throttling back up to attain a 4.6 G acceleration. Engine response continues to look good. And Centaur has begun the boost phase chill down sequence to thermally condition the RL-10 for operation. Standing by for BECO shortly.
BECO is the call for booster engine.
And we have BECO, booster engine cutoff, standing by for stage separation. And we have good indication of Atlas Centaur separation.
So there you're seeing live footage.
And we have
the
MES
rocket.
1. RL-10 operating parameters look good. Chamber pressures are stable. This will be the first of 2 burns for today's mission. This first burn will be approximately 7 minutes in length.
So, Mick, that's pretty exceptional footage there. That's live video. We will see that switch over shortly into an animation that kind of helps let us know what's happening with the rocket. But right there, a beautiful liftoff. Fun to feel that rumble in the building here as we proceed towards orbit and then towards Mars destination.
Yeah, absolutely. It was great watching an on-time liftoff of the Atlas V with that little over 2 million pounds of thrust. Cleared the tower in roughly 5 seconds. Josh, you and I worked the InSight mission, and if you recall, that mission on the West Coast took about 17 seconds to get past tower. So with those 4 solids today, this thing really got out of here and on its way. And it's, as we hear from Jesse, everything's looking nominal, and all vehicle parameters are within the design limits, and we're getting ready to come up on a main engine start for that first burn that Jesse was talking about.
So recapping this countdown to Mars, the stations began to be filled up this morning just after midnight. Preparations, fuelings, powering up, all the way through that liftoff that happened. I think, Mick, it wasn't precisely on time. I think you said it was like 10 milliseconds early. So it's pretty much dead on.
Yeah, dead on. This team does a great job job. As I said, they're very focused, very disciplined. As Tori also said, courageous. They have done a lot of work to get us to this point today through this pandemic, changed how they did some of their work, made adjustments as needed, a lot of cleaning, a lot of things, a lot of wearing their face masks, doing all kinds of things. And so this is an exciting time, not only for the JPL team in Mars 2020, but everybody that's worked this mission and for the country and the agency. So this is exciting to see. We still have a long way to go, Joshua, before spacecraft separation.
Yeah, we had a really quiet countdown today, which is phenomenal, that we got off the ground on time. And we are proceeding now that we are in the middle of the first burn. It's tough to make out, but that engine is lit and it's firing. So we are in motion. There you go. There's that animation we talked about.
The telemetry there as we switch to a TDRS-compatible data format.
TDRS.
Overall telemetry quality is very good.
The space tracking system. So there you go. This is not an actual video, but this is an animation that's driven by real data. So although we're not actually seeing the engine on screen right now, we can see that the engine is lit, and that is driven by the data that says that the engine is truly lit and we're in this burn.
Yeah, the launch vehicle continues to send telemetry to the launch team via the TDRS network, as you mentioned, and that allows them to continue to watch what's going on and make sure all their sequence of events meet their timeline. We continue on a nominal flight this morning. This first burn, as we heard earlier, will be about 6 minutes. This will get us into that park orbit around Earth, allow us to get on our way, and then get into that approximately 30-minute coast period that we're going to have.
8 minutes into flight, beginning to see the Centaur PU system balance out mass errors, seeing very stable body rates in the Centaur.
So we've mentioned 5 teams at play, and although if you were watching, hopefully you got a chance to see this in person, if not on camera, it's easy to kind of say, oh, it's over, like job done, but all 5 of these teams still very much engaged, still very much focused, because there's a lot of work ahead as we proceed through this first burn, and then a coast phase, like you mentioned, Mick, and then a second burn, and then spacecraft separation and the acquisition of signal from Mars 2020. So a lot more coming up here. Mick, I know for a launch services program, you guys manage the launch. So what does that mean? I mean, this is you guys' work in action right now.
By the way, that's the 5th team that we didn't get to mention. We talked about JPL, we talked about DOE, we talked about United States Space Force, and United Launch Alliance. LSP, we are like the brokers to select this launch vehicle and help with manage this mission. So we get our spacecraft customer, the JPL folks, they come to us. They have some certain requirements that they need for this mission. The launch services program made up of engineers and flight analysis folks, and they look at everything, they help define those requirements, and then we go out and procure a vehicle from a commercial partner. In this case, it was the Atlas 541 for the Mars 2020 mission that was needed for performance, right? As you and I have talked over the last several days, Josh, one of the things that was important for us to look at was that performance, to be able to get Mars 2020 onto that transfer orbit into solar orbit to intercept Mars in 7 months. It's kind of analogous to a football game, right? With a quarterback trying to throw a pass downfield. You need a quarterback with a lot of performance who can get that ball down there where it needs to be, and so the receiver can intercept that. In our case, 7 months later.
There you go. Yeah, it's the longest football pass ever. The Earth is the quarterback. The Atlas is the quarterback's arm. Perseverance is the football, and Mars is the receiver.
That's exactly right.
And what we also talked about is that technically you could launch to Mars at any time if you had a rocket that was powerful enough. But this is the launch period every 26 months or so, as we've talked about, that makes the most sense because you require the least amount of energy to get to Mars because it takes a lot to get there. Obviously, like the Atlas 541 is a workhorse.
Yeah, as Tori said, it's their Dominator. Right?
There you go.
I love that name for the Atlas 541. But we heard Jim Bridenstine, our NASA administrator, tell us that if we didn't make this launch period, we would be down for roughly 26 months.
It's
right?
Tough.
So the period started July 17th and goes to August 15th. Today, July 30th, was one of those launch opportunities that we had. We had a 2-hour window, and within that window, we had several opportunities.
25, actually.
Yeah.
25 opportunities.
And we launched at the beginning of the window on our first opportunity to get Mars 2020 going on its way. And that, that sounds like a lot, and it is. The flight analysis group, both at JPL, LSP, and ULA, did a lot of work to pick out those target sets and figure out where we needed to be. So they've done a great job, and we'll see how this mission continues.
So, Mig, tell us about the 2 burns required here, and we're actually coming up on the end of the first one. Ultimately, a lot of people probably, and myself included at some point, just like, why wouldn't you just keep firing the engines? Just fire all the way through and get to Mars in one shot.
So the first burn gets us into that park orbit we talked about. We've lifted off, we've left Earth, we've got into a park orbit around Earth right now, and while we're in that park orbit, we will perform some maneuvers to kind of roll Mars Perseverance and the Centaur and coast during that time, basically setting itself up looking at the sun and away from the sun to control the thermal environments that are on Mars 2020 during this coast period. That coast period will allow us to coast around into the position that we need so that we can have that second firing to get the velocity needed to head off into Mars.
Yes, and we will be back for that second burn in just under 30 minutes now. But for now, there's more to learn about this mission and all the amazing science that's involved. Daryl, back to you.
All right. Thank you very much. Great launch and great job, guys. Back outside now. To recap, an Atlas V rocket carrying Mars Perseverance rover launched on time from the Cape Canaveral Air Force Station at 7:50 a.m. Eastern Daylight Time. Well, engineers and scientists at NASA have spent years designing, as we've told you, and testing and building the Mars Perseverance rover, but we've also had help from a number of countries around the world.
Norway, France, and Spain, just to name a few, but also the European and Japanese space agencies. Here now is a toast to all of those who helped us get to Mars and help that Perseverance rover get ready to fly.
Congratulations for the successful launch of this fantastic new mission to the planet Mars.
Congratulations for the great work, despite all the obstacles set by COVID-19.
I want to congratulate everybody who made this mission happen thus far.
Thank you all for the passion and the commitment to make this epic happen.
Bravo et toutes mes félicitations, which means my heartfelt congratulations to all the teams involved in this magnificent adventure.
So you've been rewarded with a beautiful launch, and I hope you'll have a safe cruise to Mars. So well done the work so far. Let's keep going.
Skål to all teams for a successful flight.
Our international effort to reach Mars is more important now than it ever has been before.
This mission confirms that when we work together, we can overcome unbelievable challenges.
And to build a mission that truly deserves its name, Perseverance.
To persevere means to insist, to keep on, to continue trying tirelessly.
And if we persevere, we succeed. And that's why I think this is an appropriate name for this mission.
Perseverance has just started a journey to make history in Mars exploration.
It's the start of our collaboration, not only to go to Mars, but to bring back samples, the Mars Sample Return Campaign. And this is going to change our view of Mars forever.
Mars is an amazing place to explore.
Because exploration is inside the human being very nature.
Mars is essential to understand and know about our solar system, including our Earth.
We believe we can contribute to scientific discovery and the future human exploration of Mars.
This exploration of Mars is of great global significance as it contributes to the humanity's search for a home away from planet Earth.
We need robotic precursor missions like Mars 2020 Perseverance to help us understand where we need to go and what we need to do when we get to Mars, but ultimately our objective as a globe is to put humans on the surface of Mars.
Together we're counting down to Mars, so go Perseverance!
一緒に火星に進出しましょう。行け Perseverance!
Stiamo facendo insieme il conto alla rovescia per Marte. Vai Perseverance!
Ensemble, nous retournons vers Mars. Bon voyage, Perseverance!
Hop Perseverance!
Adelante Perseverance!
Hiya, Perseverance!
Together we are counting down to Mars. Go Perseverance!
And thank you so much to our international partners that you just saw there. They did a fantastic job. Now, before we let you go, we want to tell you about a little tradition that JPL has, where they did this, I guess, after the launch or before the launch with some peanuts, and Moo knows it well.
Yeah, in fact, Perseverance, little baby Percy brought us some peanuts here to divvy out, so let me give you some.
Look at there.
It actually started with a landing event. So Rangers 1 through 6 didn't go as planned, and then with Ranger 7, it landed successfully on the moon. And they were thinking, what was the difference between Rangers 1 through 6 and 7? And it was these lucky peanuts.
The lucky peanuts.
Yeah.
And so ever since then, I guess they've been having peanuts.
Exactly.
To get
every landing, and now launches.
Well, and now we've got ours in our hand. We're going to hold off because we got a little more reading to do, but we're ready to go with our peanuts.
Yes. Yes, thank you so much for watching NASA's launch coverage of Mars 2020. Stay tuned to NASA TV and our social media channels for updates to the mission.
We leave you with highlights from the thrilling liftoff earlier this morning. Take care, everyone, and remember, keep looking up. Cheers,
Cheers!
7, 6, 5, 4. Engine ignition, 2, 1, 0.
0.
Release.
And liftoff. As the countdown to Mars continues, the perseverance of humanity launching the next generation of robotic explorers to the Red Planet.
And Atlas TU has gone to closed-loop control.
Feeling weighed down? Feeling the constant pull to the Earth? We all are. It's gravity, and it's a part of every single thing we do, including our science. But what if we're 250 miles above Earth, aboard the International Space Station, a laboratory like no other that offers something we can't get on our home planet?
My name is Dr. Serena Anand-Chancellor, NASA astronaut. I recently flew to the International Space Station aboard Expedition 56 and 57. My relationship with microgravity